An array stack implements the list interface using an array A. The ith list item is stored at array index I. A counter, n, keeps track of the number of elements in the array stack. Usually, the length of A is not exactly n. The array has room for some additional elements. The getI operation is easy to implement. We just return the ith value in A. The setIx operation is just as easy to implement. We set the ith value in A equal to x. The addIx operation requires a little more work. Before we can add x at location I, n-i elements have to be shifted one position to the right to make room for x. Once this shifting is done, we can place x at array location I and increment the value of n. The special case, I equals n, is simpler, since nothing needs to be shifted. All of this assumes that there is room in A for one more element. Occasionally, we may try to add an element when A is already full. Before we can add the new element, we have to grow A. To do this, we allocate a new array of length 2n and copy all the n elements from A into this new array. This new array then becomes our next array A. After this resize operation, there is room in A to finish the addIx operation as usual. The removeI operation is implemented as expected. We first remove the ith element from A. This leaves a hole in A that we fill by shifting n-i-1 elements. Once this shifting is done, we decrement the value of n. Like adding, removing from the end of the list is faster, since nothing needs to be shifted. Eventually, if we remove enough elements, A starts to become very empty. If we reach a point where more than 2/3 of A is empty, then we resize it. As before, we allocate an array of length 2n and copy the n elements of A into this new array. This new array becomes the next array A. The array stack is a nice simple implementation of the list interface, and the running time of array stack operations are easy to analyze, except for the resize operation. To get around this, we'll ignore the cost of resize, for now. The getI and setI operations are simple array accesses that each take constant time. The addIx operation requires shifting n-i elements of A, which takes an additional O of n-i time. Similarly, the removeI operation requires shifting n-i-1 elements of A, which also takes an additional O of n-i time. So far, so good. But we can't just ignore the things we don't understand. We still have to account for calls to resize. That's what we'll do in the next module.